everyone. This is Yongguk Jung.
And Amita Singh from KTH Royal Institute of Technology, Sweden.
Yes, today we are talking about using multi-actor simulation modeling for sustainable production logistics. And we have a case studies, and this is our case study is based on the city of Truk. So let's go into our topics. So we are working on working package 2, which is the production logistics in urban logistics in the HUPMOBILE project. Our goal is improving production logistics and urban logistics. With this goal, our objectives are following like this. So first, we want to propose a planning approach and tools focusing on the flow and goods. And second, we want to analyze how inbound and outbound traffic from the port area impact transport flows and their interactions. And the main output of this working package 2 can be the simulation-based multi-level optimization model that allows stakeholders to model their own flows. So our expected application on working package 2 is optimizing flow for multi-stakeholder views, and active participant is necessary for all stakeholders. And we want to identify relevant variables for optimization and simulation. To develop a simulation model, we have choose Sumo Simulator, which is simulation of urban mobility. It is an open source simulation software and specialized for the logistics, urban logistics. As you can see, we can simulate large-scale simulation, large-scale traffic simulation, and also even if the small-scale traffic light simulation also. And it has some advantages for urban logistics simulation. So first, it is open source, so we can use many libraries which are developed for other different applications. And second, it has strong user groups, so we can refer some previous studies. And it is specialized for the mobility simulation, so it has well-structured data structure. So we can follow the data structure in Sumo simulators. To build a simulation model, we need load network, which is a map, and we need a traffic demand. Yeah, statistical data, something like origin destination metrics, can be a traffic demand, and Sumo can generate traffic flow based on the origin destination metrics. So some cities have some statistical data like the origin destination analytics, then we can use that data for our simulation model as an input data. This is our pilot case. We have developed Truk City case for our project. So Truk City has a port area, and our main focusing area is port area. As you can see, a basic scenario is like this. So ferries comes from the Baltic Sea, and it will stay specific time at the port area. And there are loading and unloading process in the port area, and trucks and passenger cars which from the ferry will go to city center or some other location in the center. And some trucks and passenger cars from ferry will load to the ferry. So we have imported the Truk City map with the OpenStreetMap, and there is some assumptions. So trucks and passenger cars traffic, we have some assumptions. We have the number of trucks cargo traffic, which is our importing and exporting. We got this data from the Port of Truk cargo statistics, and the remaining ferry capacity is assumed to be filled with the passenger cars. And as you can see in the right side, there is some route for the trucks and passenger cars. So this is our Truk case pilot. And we also have some assumption of our simulation. The trucks start to line up 4 hours before boarding for the paperwork and clearance. And passenger cars start to line up approximately 1 hour before the ferry arrives. So this is our assumption, but we can change these variables. And loading and unloading takes 20 minutes each, and loading and unloading times are divided into equal for each vehicles. And as you can see, there is some simulation cases. We have 2 simulation cases, but incoming and outgoing trucks and incoming, outgoing number of passenger cars are same as each of the cases, but the engine type is different. The first case we have used the Euro 5 engine type for each vehicles and each trucks and the passenger cars, and case 2 we have used the Euro 6 engines. So we can compare with the simulation model. So this is our sumo simulation model. In the left side, the ferry is staying at the specific point, and the light blue passenger cars are waiting for the loading, and the trucks are also waiting for the loading, and there is some trucks and passenger cars from the ferries are going to the city center. So we can analyze the simulation result with this simulation model. These are the results from the sumo simulation model. So we can calculate the current waiting time and total accumulate waiting time each of the vehicles. And we can also get some data about the amount of emissions and fuel consumptions and power consumptions also. So we can get this data from the sumo, as you can see in the right table, but also we can export this data like the text type Excel file or CSV file. So we can post-processing this data with some analytics. And we can also get some noise level from the simulation. So this is our pilot case, but the simulation can be used for the comparing some different type of scenarios. So we want to have some required input for the future, like we want to get some new map for the planned area for the load network, and we also want to have some vehicle traffic forecast and vehicle distribution or cargo distribution. Also, if we got this data, we can compare different type of scenarios, then we can give the city to the analytical results. So which scenario is the good for the fuel consumption, or which scenario is good for the traffic analysis. But we are focusing on the port area. Yeah. So these are our result, and Yannick is our main contact for our working package too. So if you have any question, you can contact with this. Yep. Thank you for listening.